Okay, so I'm coming to talk to you about how we can solve trig equations. I have three trig equations here. The first one I have here is sine x plus cotangent x is equal to 1. Same principle we're going to do as far as if you don't see a sine and cosine, make sure you change that particular trig function to a sine and cosine. Here, sine x will stay the same. Cotangent is the same as cosine x over sine x, and that's equal to 1. Well, this is nice because if you put this sine x over 1, you're going to have the sine x's cancel out, so I'm going to have cosine x is equal to 1. Now, where does cosine x equal 1? Now, we want to make sure we come up with the solution in terms of radians. So on the unit circle, you had your unit circle in front of you. Let's take a look at these points here. This is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Now, this point here is considered to be 0 radians. This point is considered to be pi over 2 radians. This point is considered to be pi radians, and this down here is 3 pi over 2 radians. So now cosine x equals 1 means what x value on the unit circle is equal to 1, and that is at the angle 0 radians. Okay, so the solution to this is x equals 0. Now, this one, sine x equals 3 cosine x. Now, in this case, we have everything in terms of sine and cosine. However, we want to solve that. All right, so we want to get the number by itself here. So in this case, we want to divide both sides by cosine x. So when we do that, 3 is left over there. Sine x over cosine x, that's equal to tan x. Okay, so now we want to try to find out where does tan x equal to 3. All right, now obviously tan x is a product of sine divided by cosine, but when does that equal 3? That's pretty difficult to solve. Well, let's see if we can do this. In this case, tan inverse of 3 is equal to some angle x. You can easily find that in the calculator, making sure you switch over to radian mode. You can just put in the expression tan inverse 3, and you would get your answer for x for that one. Now, over here, cosine x equals cotangent x. Now, again, want to change everything over to sines and cosines. This is already a cosine, so that's cosine of x is equal to, this is going to be cosine x over sine x. That's the quotient identity. Now, what I want to make sure that I do is, I want to make sure I bring this over to the other side so I can make only one expression in terms of cosine or sine. Now, in order to bring this over to the other side, I would have to multiply by its reciprocal. Okay, so over here I'm going to multiply by sine x over cosine x. Now, if I put that over 1, what's going to happen, this would cancel, so I have 1 over here. And then here, cosine x's would cancel, so I'll have sine x. So now, where does sine x equal 1? Let's go back to the unit circle here. Well, if you have the unit circle in front of you, that's a better illustration than my makeshift unit circle that I drew on here. So, sine of what angle gives you 1? So basically, you go to the angle that has a y value of 1. That angle is at x equals pi over 2.